Hello and welcome to the group video on explaining 4.5 problem 3, which deals with the chain rule. The problem 3 reads, if z is equal to xy cubed and x is equal to e to the negative t and y is equal to sine of t, find the following derivative using the chain rule. Enter your answer as a function of t. And so the process that we're going to go ahead and use for this is that we're going to be setting up a tree diagram. We're going to set up the function in terms of dz over dt, and we're going to solve that function in terms of t. What we're going to do is we're going to go ahead and set up the equation. So z is equal to xy cubed, and then that's also equal to f of x and y, and also f of x in terms of t and y in terms of t as well. And then you can also replace it with z in terms of x in terms of t and y in terms of t. And so the reason why we put t and nothing else is because when we look at the equations relating to x and y, we only see a t variable there, because those are the only other variables in those equations, because the rest of the equation is arguments. So we've got an e of t, and then we've got a sine here, which are just the arguments. So no other variables other than t. So that's going to be making this chain rule relatively simple to go ahead and compute. So let's go ahead and get started. And our first step is going to be making that tree diagram. And so how we're going to start this off is that we're going to start off with whatever the function started with. So ours is with z. So z is going to be kind of the top of the tree here. And it's going to be z at the way top. And so to figure out where to go from here, whether or not we should split or branch, we're going to look at whether or not it's in terms of other things. So for this one specifically, we see that z is in terms of x and y. So we're not going to worry about the rest of this stuff to the right of that just yet, but we're focusing just on this x and y portion right here. So let's go ahead, and since there's two of them, we're going to branch off. One we're going to label x and one we're going to label y. Doesn't matter which one you put. I just do it this way to keep that consistency of x is on the left and y is on the right. And so then we can ask ourselves, does x and y get broken up into anything, or are there any other, is it in functions of something else? And so what we do is we look either right here, or we can go back to the original equations of x and y and see that it's in terms of t. So it says that x is equal to e to the negative t, and then y is equal to the sine of t. So it's not in terms of x, or it's not in terms of y, it's in terms of t. So since it's nothing else, it doesn't branch, but to show that it continues, we're going to draw two straight lines down, and then we're going to have that end off at t. Because it doesn't split into anything else. It doesn't split into u or v or w, nothing else. But so now what we do here is to figure out whether or not we're going to be taking the partials or the flat back d derivatives. We're going to look at how we get there. So I like to start from the bottom of the tree diagram. So we're going to be looking at t first, and then we're going to be looking at x. And so if we follow this road, you could think of it, if we follow this road all the way up, we hit x, and we see that there's only one road and it goes to z. And before we head to z, we gotta keep track of where we've been. X itself does not split off. It's going to be a straight back d derivative of x over t. And so we're going to go over to the y section and see that y doesn't split off like x, so it also is going to be a straight back dy over dx. And so keeping with this continuity, or keeping consistency, we're going to go back to blue, this x side, and we're going to travel from x, because we've been from t to x, and now we're going to go to z. And we look to the left, and we realize that z splits off. And z splits off into terms of x and y. So that's going to make this road a partial road. And it's going to be the partial of z over the partial of t. And then we're going to come over back to the red side, and I'm sure you figured it out by now, but this is also going to be a partial because z itself splits off. So you'll have partial of z. This is going to be the partial of z over the partial of t. And so what this is going to do is this is going to help us set up the equation for dz dt. So we're going to go ahead and come over here, and we're going to write that out in terms of all the derivatives we just found. And so what we're going to do is we're going to see off to this left side, if we travel back down towards t from the z spot, we're going to hit that partial z over partial t, and then we're going to hit that dt dx, or dx dt. And so if we go that way, we're going to find that it's going to be the partial of z over the partial of t. And then we're going to multiply that because we're following the same road here, right? We're going to be following the left road, right? So those ones are going to be multiplied, and it's going to be dz over, or partial of z over partial of t, times dx over dt. And since it doesn't go further than t, we can stop there for the x's and go ahead and move over to the y area. And that's going to be addition because it comes from the z function. And then we're going to treat the y branch like we did the x. So we're going to hit that partial of z over partial of y. And then we're going to be multiplying that by dy dt. And so now what we can start to do is we can start to take the derivatives of these functions right here that we just found. And so we're going to go ahead and start off with the partials of z. So partial of z over partial x. And we're going to be taking the function z and holding the y constant. And if we go up here, that z function is going to be z is equal to xy cubed. So if we hold the y constant, we're just going to get y cubed. And then same goes for partial of z over partial of y, is we're going to get, if we hold the x constant, we're going to get 3y squared times x. Now, this guy right here and this guy right here. So now let's go ahead and find the derivatives of x and with regards to t. So dx dt. It's going to be equal to the negative e to the negative t. So now what we're going to do is we're going to find dy over dt. And so when we come back up here, we're going to find that it's going to be y is equal to sine of t. So that's going to be a pretty easy one at cosine of t. And now since we've found every part of dz dt, we can now start plugging in values for that. So partial of z over partial x is going to be that y cubed. And then we're going to be multiplying that by the derivative of x over dt. So that's going to be negative e to negative t. We're going to be adding on that partial z over partial y, which is going to be 3y squared times x. And then we're going to finish it off with the derivative of y, which is going to be cosine t. And again, what we did right there is we just plugged in these values. So this guy went here, this guy went here, and so on and so forth. This guy went there, and then this guy went there. Now, if we remember the steps that we were doing, made the tree diagram, so we finished that. We set up the function, and then we're going to solve the function in terms of t. How we're going to do that is we're going to take the original values for x and y, and we're going to go ahead and plug them into the new equation that we found. So x is going to be e to the negative t, and y is going to be equal to the sine of t. And so what we're going to do is we're going to plug x and y into wherever we find x's and y's. So it's going to be equal to sine cubed of t. And then since this one is already in terms of t, this is okay to leave. We don't have to substitute it at all there. So we're going to add 3 times sine squared, since it's squared, of t, and multiply that by the function of x, which is going to be e to the negative t. And then we're going to multiply that by cosine of t. And so what we're going to find is that this is going to be our final answer. It's going to be sine cubed of t times negative e to the negative t plus 3 times sine squared t times e to the negative t cosine of t.